Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Mudhukumaran Institute of Technology. Today we are going to learn the subject 3D Printing and Design. The subject code is CCS 331, Regulation 2021. Today we are going to see about print head consideration. There are three types: continuous inject, thermal inject and piezoelectric drop on demand. So today we are going to see about these in detail. First of all, the key factors of print head consideration. First one is print quality, that depends on droplet size, placement accuracy and nozzle uniformity. Smaller droplets have higher resolution and smoother surface finish. Second one, print speed, influenced by firing frequency, number of nozzles and motion synchronization. High speed heads enable faster layer deposition without sacrificing accuracy. Third one is print head durability. It's determined by material wear resistance and thermal mechanical stability, and it's critical for industrial and continuous operation printers. Fourth one is ink variety. Its ability to print different viscosities and material types and supports photopolymers, bio-inks, ceramic inks and metal nanoparticle inks. Fifth one is cost. It includes initial print head price and replacement cost, and also high precision head cost more but offer better performance and lifespan. Sixth one is maintenance. Regular cleaning, purging and nozzle checks required, and also good maintenance reduces clogging, downtime and print defects. An ideal print head balances high quality, fast speed, long durability, wide ink compatibility, reasonable cost and low maintenance. Next one is continuous inject technology. So what is CIJ? CIJ means continuous inject technology, in which ink droplets are generated continuously even when no printing is required. Only the required droplets are directed to the substrate, the rest is recycled. So the key features of this CIG is continuous droplet generation, electrostatic deflection controls droplet placement, ink recycling system, non-contact printing. Here we can see the working principle of CIJ. A continuous inkjet printer continuously produces a stream of tiny ink droplets. These droplets are electrically charged and controlled to print characters on the surface. The main parts are ink supply. It is supplies liquid ink to the inkjet head under pressure. Then inklet head, that is nozzles, it breaks the continuous ink stream into small droplets using vibration. Next one is charge electrode. It gives electrical charge, either positive, negative or no charge to selected droplets. Next one is deflector plates. It creates an electric field to deflect or bend the path of charged droplets. Next one is substrate, where the surface on which printing is done. And next one is recycling system, that collects unused droplets and sends them back to the ink tank. Now we can see this working. So ink is pumped from the ink supply to the nozzle, and the nozzle forms a continuous stream of ink. Next, the stream breaks into tiny droplets. As droplets pass through the charge electrode, required droplets are charged, then unwanted droplets are left uncharged. Charged droplets pass between deflector plates. Then they bend in different directions depending on the charge. The deflected droplets hit the substrate and form characters. Uncharged droplets go straight into the recycling system and they are reused. Next, the continuous inkjetting printers generate a continuous stream of ink droplets from a nozzle. These droplets are then controlled using a electrostatic field to deposit ink selectively on a substrate. So electrostatic deflection is the droplets pass through a charging electrode. Selected droplets are electively charged. The charged droplets are deflected by electrostatic plates towards the substrate to form the desired pattern, while uncharged droplets are collected and recirculated back into the ink system. In 3D printing, the continuous inkjet process is repeated layer by layer, where each deposited layer contributes to building the final 3D object. The image shown represents the single color continuous inkjet printing compared to drop and demand system. The CIJ images appear more pixelated due to a large droplet size and the continuous droplet formation. However, the major disadvantage of CIJ is its extremely high printing speed, making it well suited for rapid deposition and high throughput applications. So next one is thermal inkjet technology. This process works by using many tiny nozzles that rapidly heat the ink. As the ink temperature increases, a vapor bubble forms inside the nozzle. The rapid expansion of this bubble forces a small droplet of ink out through the nozzle and on the surface. When the bubble collapses, fresh ink refills the nozzle, ready for the next filling cycle. There are 4 steps in thermal inkjet technology. Step 1 is heating the ink. Step 2 is bubble formation. Step 3, ink ejection. And the final step is bubble collapse. So in the previous diagram, from that, first of all, the first step is heating stage. So that is also called as roof shooter. It fills the pressure chamber. The heater is switched on and the heater rapidly heats the ink. A small vapor bubble begins to form. Next one is bubble formation, that is called a side shooter stage. Here the vapor bubble expands quickly due to heat. This creates high pressure inside the chamber. The pressure forces a tiny droplet of ink out through the nozzle. And next, cooling and refill stage, that is the back shooter system. Here the heater is switched off. The bubble collapses as the ink cools. Pressure decreases inside the chamber. Fresh ink flows into the chamber from the reservoir. This system is ready for the next droplet. So this process is incredibly fast, allowing TIJ, that is thermal inkjet technology printers, to produce precise and detailed prints at the high speeds, making them suitable for both commercial and industrial use. So the working principles of thermal inkjet. So here the step 1 is ink supply to the nozzle. So liquid build material is supplied from the reservoir to the nozzle chamber using a pump. A resistive heating element is located inside the chamber near the nozzle. The substrate, that is the build platform, is positioned below the nozzle. Next, step 2, the bubble formation. An electric pulse is applied to the resistive element. The element heats up rapidly, causing the liquid material to vaporize locally. This rapid heating produces a gas, that is vapor, bubble inside the chamber. Next, step 3, that is bubble expansion. The gas bubble expands suddenly, creating high pressure inside the chamber. This pressure forces a small volume of liquid towards the nozzle. Next, step 4, droplet ejection and bubble collapse. The expanding bubble ejects a precise droplet of material onto the substrate. Once the heating pulse stops, the bubble collapses. Fresh material refills the chamber, preparing the nozzle for the next droplet. So next one is piezoelectric drop and demand. So this printing ejects ink only when required. Each nozzle contains a piezoelectric actuator that changes shape when an electric voltage is applied. When the current is removed, the crystal shrinks again, drawing up ink into the printer head. This piezoelectric drop and demand inkjet printers uses this piezoelectric element to generate a controlled pressure pulse inside the ink chamber, ejecting ink droplets only when required. This makes it a non-contact printing technique, ensuring precise droplet placement without touching the substrate. Due to its high repeatability and the ability to deposit droplets of different compositions, piezoelectric DOD inkjet printing is widely applied in 3D printing, biomedicine and electronics, where accuracy and material flexibility is critical. So we can see the step-by-step working here. The ink fills the ink chamber. Then when an electrical voltage is applied, the piezoelectric actuator changes shape. It bends or contracts. This change in shape reduces the volume of the ink chamber. The reduction in volume increases pressure inside the chamber. The pressure forces a small ink droplet out through the nozzle. When the voltage is removed, the actuator returns it to the original shape. The chamber refills with the ink, ready for the next droplet. Next, how it works. This piezoelectric element activation. Here a voltage or electric impulse is applied to the piezoelectric element inside the print head. Next, pressure pulse generation. Here the piezoelectric element deforms, producing a pressure pulse within the ink chamber. Next, drop ejection. Here the generated pressure pulse forces an ink droplet out of the nozzle toward the substrate. Finally, ink filling. When the voltage is removed, the piezoelectric element returns to its original shape, creating suction that refills the nozzle with the ink for the next cycle. So here the main components are pump, pressure regulator, ultrasonic vibrator, that is piezo element, then nozzle, charge electrode, high voltage deflection plates, recycling gutter, ink recycling system. Finally substrate. So we can see the step-by-step working. The ink supply and pressure control. Ink is pumped continuously using a pump. The pressure regulator maintains constant pressure. This creates a continuous ink stream towards the nozzle. Next, droplet formation. Here the piezo element produces ultrasonic vibrations. These vibrations break the continuous ink stream into a uniform droplets. Charging of droplets. As droplets pass through the charge electrode, selected droplets are electrically charged. Required droplets are charged differently depending on the printing pattern. Unwanted droplets remain uncharged. Next one is deflection process. Droplets pass between high voltage and deflection plates. Charged droplets are deflected due to the electric field. The deflected droplets hits the moving substrate and form characters. Uncharged droplets move straight. Next, ink recycling. Here, unused droplets are collected by the recycling gutter. The ink is sent back through a recycling line. The process repeats continuously. So finally, the advantages of this, there is non-contact printing, then high repeatability, suitable for various inks, then versatile applications, high resolution printing, and multi-liquid and multicolor printing. So in the next video, we can see about material formulation for jetting. Thank you.